Hey friends, I'm Window, and recently, the James Webb Space Telescope detected something incredible, a star made of a kind of matter we can't even see. We can't look at it directly, but we can observe the effects it has on its surroundings. And based on those effects, we can actually predict its presence in the universe. Yep, I'm talking about a dark matter star. Now, as many of you probably know, dark matter is this mysterious kind of matter that doesn't absorb or reflect light, it's completely invisible. But could this 90-year-old cosmic mystery finally be solved? And did dark matter actually give birth to the first stars and even black holes in the universe? Let's dive in. As you know, dark matter is one of the biggest unsolved mysteries in physics. Even today, scientists haven't cracked it. And to understand the connection between dark matter stars and regular stars, we need to go back in time. Right back to the very moment the Big Bang happened, the birth of our universe. Immediately after the Big Bang, positively charged hydrogen atoms started forming. But at the same time, the universe was expanding and cooling very rapidly. Because of this rapid expansion, just 20 minutes after the Big Bang, something crucial changed. The energy of the universe dropped so much that hydrogen fusion just stopped. But wait, we do have stars today. So, what triggered their formation? Here's where things get interesting. Scientists noticed a mathematical inconsistency. Basically, their calculations didn't add up unless something else was present in the early universe. That something was predicted to be a special kind of matter, and this is what we now call dark matter. As soon as you add dark matter to the Big Bang theory, suddenly the calculations start making sense. It's like missing puzzle pieces just clicked into place. And here's the thing, dark matter doesn't interact with regular particles. It only interacts with one force, gravity. So just remember for now, dark matter and gravity? Yeah, they're best friends. Solid bond. Now, when dark matter was first theorized in the 1930s, scientists had no clue where it came from. But by the 1980s, particle physicists suggested that dark matter might have formed during the Big Bang, just like regular matter. Only difference? It was made of a different class of subatomic particles called WIMPs. Weakly interacting massive particles. This led to the idea of a special category called cold dark matter. So when a bunch of these WIMPs gathered together, their combined gravity started pulling in normal matter. And scientists now believe this is exactly what happened during the early universe. These clumps of dark matter pulled in hydrogen atoms, causing them to collide, which raised their energy levels, kickstarting the first fusion reactions. That's why some researchers proposed that the first stars in the universe might have actually been made of dark matter. But not everyone agreed. There were scientists who strongly rejected the idea of dark matter stars. Then came a discovery that turned everything upside down. New research showed that the supermassive black hole at the center of our Milky Way, Sagittarius A*, may have formed from dark matter particles. 3 major universities were trying to solve a key question. How could a black hole this massive form just 200 million years after the Big Bang? Especially when, according to current models, stars themselves didn't form until around 100 to 400 million years after the Big Bang. And we know, stars explode as supernovae form black holes, and it usually takes over 1 billion years for a black hole to grow that big. So something wasn't adding up. Either the Big Bang model was off, or our understanding of black holes was incomplete. To figure this out, researchers used a supercomputer to simulate the early universe. Guess what they found? Dark matter particles formed a donut-shaped disk. That disk evolved, and eventually collapsed, into a supermassive black hole. All in just 270 million years. This gave new support to the idea of dark matter stars. Now here's where astrophysicist Catherine Fries and her team come in. They created a theoretical model for how dark matter stars could form. According to the model, these stars contain both dark matter and normal matter like hydrogen and helium. Let's break this down. Regular stars begin as cold, dark hydrogen clouds, called nebulae. Gravity tries to pull the gas in, while gas pressure tries to push it out. Eventually, gravity wins. The cloud collapses in on itself, becomes denser, hotter, and a protostar is born. Over 500,000 years, this protostar heats up to about 15 million degrees. Enough for hydrogen atoms to start fusing into helium, and that's how a star is born. Now imagine something similar, but instead of gravity from normal hydrogen. It's dark matter gravity pulling atoms in. That's called dark matter capture. These particles give enough energy to kickstart fusion. And here's the craziest part. Even though it's made from dark matter, a dark star would shine up to 10 billion times brighter than our sun. Okay, so up until now, this was all theory and simulation. Until James Webb Space Telescope, JWST, stepped in. Last year, JWST discovered 3 strange galaxies. Aged between 13.4 and 13.6 billion years, just 200 million years after the universe began. Huge red flag, because galaxies aren't supposed to mature that fast. Catherine's team suggested that maybe these weren't galaxies at all. Maybe these were dark matter stars. To test this, they used a simulation software called Cluster. They input the properties of a dark star, predicted its light absorption, and created a framework. Then they compared that with JWST's images. But there was a problem. The telescope only gave images, not full spectral data. So they used color filters to extract approximate spectral data. Red, green, and blue, and found their peak intensities. Then they plotted the actual telescope data against the simulated dark star model. And guess what? The graphs matched almost perfectly. That was a huge moment. It showed that the objects JWST saw might very well be dark matter stars. That was a huge moment. It showed that the objects JWST saw might very well be dark matter stars. So, Catherine and her team may have actually proven that dark matter stars exist. But, and this is important, even she later admitted that there were some loopholes in her method. So, is the dark matter mystery really solved? Well, that part is still up for debate. But what do you think? Are dark matter stars real? Did they help create our universe? Let me know your thoughts in the comments. And hey, if you found this clip interesting, don't forget to check out the full video. Link is in the description below.